Basics of C programming. 1. Introduction to programming paradigms. C. Introduction. The programming language, C, was developed in the early 1970s by Dennis Ritchie at Bell Laboratories. Although C was initially developed for writing system software, today it has become such a popular language that a variety of software programs are written using this language. The greatest advantage of using C for programming is that it can be easily used on different types of computers. Many other programming languages such as C++ and Java are also based on C, which means that you will be able to learn them easily in the future. Today, C is widely used with the Unix operating system. Programming paradigms. In computing, a program is a specific set of ordered operation for a computer to perform. The process of developing and implementing various sets of instruction to enable a computer to perform a certain task is called programming. Programming paradigms include 1. Imperative programming paradigms. 2. Structured programming paradigms. Commands show how the computation takes place, step by step. Each step affects the global state of the computation. 2. Structured programming paradigms. It is a kind of imperative programming where the control flow is defined by nested loops, conditionals, and subroutines, rather than via gotos. Variables generally local to blocks. 3. Object-oriented programming, OOP, paradigms. It is a programming paradigms based on the concepts of objects, which may contain data, in the form of fields, often known as attributes, and code, in the form of procedures, often known as methods. 4. Declarative programming paradigms. The programmer states only what the results should look like, not how to obtain it. No loops, no assignments, etc. Whatever engines that interprets this code is just supposed go gets the desired information and can use whatever approach it wants. 5. Functional programming paradigms. In functional programming, control flow is expressed by combining functional calls, rather than by assigning values to variables. 6. Procedural programming paradigms. This paradigms includes imperative programming with procedure calls. 7. Event-driven programming paradigms, in which the flow of the program is determined by events such as user action, mouse clicks, key presses, sensor output, or message from other program threads. It is the dominant paradigms used in GUI and other applications that are centered on performing certain action in response to user input. 8. Flow-driven programming paradigms. Programming processes communicating with each other over predefined channels. 9. Logic programming paradigms. 9. Logic programming paradigms. Here programming is done by specifying a set of facts and rules. An engine infers the answer to question. Thus, constraints programming paradigms. An engine finds the value that meet the constraints. One of the characteristics of a language is its support for particular programming paradigms. For example, Smalltalk has direct support for programming in the object-oriented way, so it might called an object-oriented language. Very few languages implement a paradigms 100%. When they do, they are pure. It is incredibly rare to have a pure OOP language or a pure functional language. A lot of language will facilitate programming in one or more paradigms. If a language is purposely designed to allow programming in many paradigms is called a multi-paradigms language. Application of C. 1. Operating System. 2. Embedded System. 3. GUI, Graphical User Interface. 4. New Programming Platforms. 5. Google 6. Mozilla Firefox and Thunderbird 7. MySQL 8. Compiler Design 9. Assemblers 10. Text Editors 11. Drivers 12. Network Devices 13. Gaming and Animation. Features of C programming. Advantages. Features of C programming. Advantages. Disadvantage of C. C does not provide OOP. There is no concepts of namespace in C. C does not provide binding or wrapping up of a single unit. C does not provide constructor and destructor. Structure of C. Documentation section. The documentation section consists of a set of comment lines giving the name of the program, the author and other details, which the programmer would like to use later. Link section. The link section provides instructions to the compiler to link functions from the system library such as using the hashtag include directive. Definition section. The definition section defines all symbolic constants such using the hashtag define directive. Global declaration section. There are some variables that are used in more than one function. Such variables are called global variables and are declared in the global declaration section that is outside of all the functions. This section also declares all the user-defined functions. Main function section. Every C program must have one main function section. This section contains two parts, declaration part and executable part. Declaration part. The declaration part declares all the variables used in the executable part. Executable part. There is at least one statement in the executable part. These two parts must appear between the opening and closing braces. The program execution begins at the opening brace and ends at the closing brace. The closing brace of the main function is the logical end of the program. All statements in the declaration and executable part end with a semicolon. Subprogram section. If the program is a multifunction program, then the subprogram section contains all the user-defined functions that are called in the main function. User-defined functions are generally placed immediately after the main function, although they may appear in any order. All section, except the main function section, may be absent when they are not required.
C programming. Data types. A data type in C programming is a set of values and is determined to act on those values. C provides various types of data types which allow the programmer to select the appropriate type for the variable to set its value. The data type in a programming language is the collection of data with values having fixed meaning as well as characteristics. Some of them are integer, floating point, character, etc. Usually, programming languages specify the range values for given data type. C data types are used to identify the type of a variable when it declared, identify the type of a variable when it declared, identify the type of a variable when it is declared. ANSI provides three types of data types. 1. Primary, built-in, data types, void, int, char, double and float. 2. Derived data types, array, references, and pointers. 3. User-defined data types, structure, union, and enumeration. Primary data types. Every C compiler supports 5 primary data types. Void, as the name suggests, it holds no value and is generally used for specifying the type of function or what it returns. If the function has a void type, it means that the function will not return any value. Int used to denote an integer type. Char used to denote a character type. Float, double used to denote a floating point type. Int asterisk, float asterisk, char asterisk used to denote a pointer type. Declaration of primary data types with variable name. After taking suitable variable names, they must be assigned a data type. Derived data types. C supports 3 derived data types. Arrays. Arrays are sequences of data items having homogeneous values. They have adjacent memory locations to store values. References. Function pointers allow referencing functions with a particular signature. Pointers. These are powerful C features which are used to access the memory and deal with their addresses. User-defined data types. C allows the feature called type definition, which allows programmers to define their own identifier that would represent an existing data type. Structure. It is a package of variables of different types under a single name. This is done to handle data efficiently. The struct keyword is used to define a structure. Union. These allow storing various data types in the same memory location. Programmers can define a union with different members, but only a single member can contain a value at a given time. Enum. Enumeration is a special data type that consists of integral constants, and each of them is assigned a specific name. The enum keyword is used to define the enumerated data type. Constants. A constant is a value or variable that can't be changed in the program. There are different types of constants in C programming. List of constants in C. Decimal constant, real or floating point constant, octal constant, hexadecimal constant, character constant, string constant. 2 ways to define constant in C. There are 2 ways to define constant in C programming. 1. Constant keyword. 2. Define preprocessor. \character constant. C supports some character constants having a backslash in front of it. The lists of backslash characters have a specific meaning, which is known to the compiler. They are also termed as escape, sequence, enumeration constants, and enum is a keyword. It is a user-defined data type. All properties of the integer are applied to the enumeration data type, so the size of the enumeration data type is 2 bytes. It works like an integer. It is used for creating a user-defined data type of integer. Using an enum, we can create a sequence of integer constant values. Keywords. A keyword is a reserved word. You cannot use it as a variable name, constant name, etc. There are only 32 reserved keywords in the C language. Operators. Operator is a special symbol that tells the compiler to perform a specific mathematical or logical operation. Arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, ternary or conditional operators. Priority. This represents the evaluation of the expression starts from the what operator. Associativity. It represents which operator should be evaluated first if an expression contains more than one operator with the same priority. Precedence of operators. The precedence rule is used to determine the order of application of operators in evaluating sub-expressions. Each operator in C has a precedence associated with it. The operator with the highest precedence is operated first. Associativity of operators. The associativity rule is applied when two or more operators are having the same precedence in the sub-expression. An operator can be left to right associative or right to left associative. Expression. An expression is a sequence of operators and operands that specifies the computation of a value. Simple expressions and compound expressions. An expression that has only one operator is known as a simple expression. An expression that involves more than one operator is called a compound expression. IO statement. The IO functions are classified into two types: formatted functions, unformatted functions. Formatted input function, SCANF. It is used to get data in a specified format. It can accept different data types. Formatted output function, PRINTF. The printf function is used to print data of different data types on the console in a specified format. Unformatted input function, getchar, gets. Getchar. This function reads a single character of data from the standard input. Getch accepts only a single character from the keyboard. The character entered through getch is not displayed on the screen. Getch accepts only single character, but getch displays the entered character in the screen. Unformatted output function, pucher, puts. Pucher. This function prints one character on the screen at a time. Puch displays any alphanumeric characters to the standard output device. It displays only one character at a time. Puts. This function prints the string or character array. Assignment statement. The assignment statement has the following form. Syntax. Variable equals expression, constant, variable. Its purpose is saving the result of the expression to the right of the assignment operator to the variable on the left. Here are some rules. If the type of the expression is identical to that of the variable, the result is saved in the variable. Otherwise, the result is converted to the type of the variable and saved there. If the type of the variable is integer while the type of the result is real, the fractional part, including the decimal point, is removed, making it an integer result. If the type of the variable is real while the type of the result is integer, then a decimal point is appended to the integer, making it a real number. Once the variable receives a new value, the original one disappears and is no more available. The expression on the right-hand side of the assignment statement can be an arithmetic expression, a relational expression, a logical expression, a mixed expression. Decision-making statements. Decision-making statement is depending on the condition block need to be executed or not, which is decided by condition. If the condition is true, statement block will be executed. If condition is false, then statement block will not be executed. In this section we are discuss about if then else, and switch statement. In C language there are three types of decision-making statement. If else, switch if statement. If then is most basic statement of decision-making statement. It tells the program to execute a certain part of code only if particular condition is true. Constructing the body of if statement is always optional. Create the body when we are having multiple statements. For a single statement, it is not required to specify the body. If the body is not specified, then automatically condition part will be terminated with next semicolon. If-else statement. In general, it can be used to execute one block of statement among two blocks. In C language, if and else are the keyword in C. In the above syntax, whenever condition is true, all the if block statement are executed remaining statement of the program by neglecting else block statement. If the condition is false, else block statement remaining statement of the program are executed by neglecting if block statements. Looping statements. Sometimes it is necessary for the program to execute the statement several times, and C loops execute a block of commands a specified number of times until a condition is met. What is loop? A computer is the most suitable machine to perform repetitive tasks and can tirelessly do a task tens of thousands of times. Every programming language has the feature to instruct to do such repetitive tasks with the help of certain form of statements. The process of repeatedly executing a collection of statements is called looping. The statements get executed many numbers of times based on the condition. But if the condition is given in such a logic that the repetition continues any number of times with no fixed condition to stop looping those statements, then this type of looping is called infinite looping. C supports following types of loops: while loops, do while loops, for loops, while loops. C while loops statement allows to repeatedly run the same block of code until a condition is met. While loop is a most basic loop in C programming. While loop has one control condition, and executes as long the condition is true. The condition of the loop is tested before the body of the loop is executed, hence it is called an entry-controlled loop. Do while loops. C do while loops are very similar to the while loops, but it always executes the code block at least once and furthermore as long as the condition remains true. This is an exit-controlled loop. Preprocessor directives. The C preprocessor is a microprocessor that is used by compiler to transform your code before compilation. It is called micropreprocessor because it allows us to add macros. Preprocessor directives are executed before compilation. Include used to paste code of given file into current file. It is used include system-defined and user-defined header files. If included file is not found, compiler renders error define used to define constant or micro substitution. It can use any basic data type. Undef used to undefine the constant or macro defined by define. If def checks if macro is defined by define. If yes, it executes the code, otherwise else code is executed, if present. Ifndef checks if macro is defined by define. If yes, it executes the code, otherwise else code is executed, if present. If evaluates the expression or condition. If condition is true, it executes the code, otherwise else. If or else or and if code is executed if expression and if else evaluates the expression or condition if condition of if is false. It can be used with if, elif, ifdef and ifndef directives. Else. Error indicates error. The compiler gives fatal error if error directive is found and skips further compilation process. Pragma used to provide additional information to the compiler. The pragma directive is used by the compiler to offer machine or operating system feature. Compilation process. C is a high-level language and it needs a compiler to convert it into an executable code so that the program can be run on our machine. How do we compile and run a C program? Below are the steps we use on an Ubuntu machine with GCC compiler. We first create a C program using an editor and save the file as filename. C filename, C. The diagram on right shows a simple program to add two numbers. Compile it using below command. GCC wall filename, CO filename. The option wall enables all compilers warning messages. This option is recommended to generate better code. The option O is used to specify output file name. If we do not use this option, then an output file with name a.out is generated. After compilation, executable is generated and we run the generated executable using below command. File name. What goes inside the compilation process? Compiler converts a C program into an executable. There are 4 phases for a C program to become an executable. 1. Pre-processing. 2. Compilation. 3. Assembly. 4. Linking. By executing below command, we get the all intermediate files in the current directory along with the executable. $gcc wall save temps filename, co filename. The following screenshot shows all generated intermediate files. Let us one by one see what these intermediate files contain. Pre-processing. This is the first phase through which source code is passed. This phase include removal of comments, expansion of macros, expansion of the included files. The pre-processed output is stored in the filename, I. Let's see what's inside filename, I using v filename, I. In the above output, source file is filled with lots and lots of info, but at the end our code is preserved. Analysis. Printf contains now a plus b rather than add, a, b, that's because macros have expanded. Comments are stripped off. Include stdio. H is missing, instead we see lots of code. So header files has been expanded and included in our source file. Compiling. The next step is to compile filename, I and produce an intermediate compiled output filename, s. This file is in assembly level instructions. Let's see through this file using filename, s. Assembly. In this phase the filename, s is taken as input and turned into filename, o by assembler. This file contains machine-level instructions. At this phase, only existing code is converted into machine language. The function calls like printf are not resolved. Let's view this file using filename, o. Linking. This is the final phase in which all the linking of function calls with their definitions are done. Linker knows where all these functions are implemented. Linker does some extra work also. It adds some extra code to our program which is required when the program starts and ends. For example, there is a code which is required for setting up the environment like passing command line arguments. This task can be easily verified by using size filename, o and size filename. Through these commands, we know that how output file increases from an object file to an executable file. This is because of the extra code that Linker adds with our program. Thank you.